Assalamualaikum everyone, welcome to Fundamentals of Programming course. In today's session we will be discussing about how we can pass arrays to the functions. But before diving deep into the understanding of the actual topic, we need to clear some basic concepts first, some of which we studied last time. If you have not watched that video, you can go on that video on that link here. Let's start today's session. First of all, let's revise some of the pointer basics that we studied last time. Yeah, pointers, we know that pointer variables are slightly different from the normal variables. Normal variables are usually used to hold certain values. However, pointer variables are used to hold addresses that are basically of some other variables. Similarly, while defining the pointer variables, we need to put an asterisk before them. However, while defining the normal variables, we do not need to put an asterisk before them. So these are basically the fundamental differences in the pointers and the normal variables. So let's start looking at how the pointer variables hold the addresses and how we can access the values stored at those addresses. So we know that if we have a 4 GB RAM, our addresses are basically 8 hexadecimal digits long, because 8 hexadecimal digits equate to 32 bits, and 2 raised to the power 32 is basically 4 giga. So if we have to access 4 GB of RAM, our hexadecimal addresses are basically 8 hexadecimal digits long. So whenever we define a certain variable, and here we have initialized it as well, what happens is in the memory is that operating system gives a certain location in the RAM to that particular variable that is free at that moment. So for example, the first 4 bytes, let's say, were occupied by some other variable or some other data in the RAM, and the free bytes that operating system finds for the variables of our program basically start from here. So how does the operating system store those variables in the memory? Is basically, it basically allocates 4 bytes here to the variable 1, vr1, because the first variable to be defined was vr1, and it will contain the value 5, and it will have the address, basically it will have the starting address from where the free bytes were starting. So it will have the address 00000004. That is actually the 5th byte of the RAM, because we have assumed that upper 4 bytes were the bytes that were already occupied, so they cannot be assigned any value, so they cannot be assigned any memory location. That memory location cannot be assigned to our variables of the program. So this was the first variable in the memory. Similarly, the second variable will be stored right after that. There is a box that is 4 bytes long and holds the value 10 and is named vr2. The address of this particular variable will be 00000008. All these hexadecimals are in all these addresses are in hexadecimal. You should know that. Also, you can see that the starting address of this particular variable is 4 bytes after the starting address of the first variable, because the integer is a data type that is 4, whose variables are 4 bytes long. Similarly, variable 3 occupies the next 4 bytes and it holds the value 15 and it has the address C, because after 8, 9 we go to A in hexadecimal counting, 9 A B C, and then D E F, and after that we go to 10 in hexadecimal. So this 10 in hexadecimal basically counts to 16. So this is basically what is happening at the back end when we are defining and initializing our variables. Now we are storing the addresses of those variables into the pointers, into the separate pointers. Each pointer basically is associated with the single variable. The ptrvr1 pointer variable 1 is basically associated with the variable 1 in this example. Similarly, ptrvr2 is basically associated with vr2, and PTR VR3 is associated with VAR3. So what happens is that when we have to define a pointer variable, we have to put an asterisk before their names, just like normal variables don't have an asterisk before their name, or with the data type the pointer variables need to have that asterisk in order to be differentiable by the compiler, that either they are normal variables or the pointer variables. Similarly, the normal variables hold some values. However, we know that pointer variables hold some addresses that are of some other variables. So basically, this is a pointer variable, meaning pointer variable 1, PTR VR1 is a pointer to an integer. So basically, PTR VR1 is pointing to the address of a variable that itself is an integer and is holding the address of the variable 1. So pointers hold addresses, we know that. Similarly, PTR VR2 is a pointer to an integer and holds the address of VR2. Similarly, PTR VR3 is a pointer to an integer and holds the address of VR3 variable. So this is this variable, this pointer variable PTR VR1 will be holding this particular address, and this particular pointer variable PTR VR2 will be holding this particular address, and this PTR VR3 will be holding this particular address. So when we display them on the screen, how are they displayed? They are basically displayed like 0x 0000 and 0004. This is basically PTR VR1's value. Similarly, PTR VR2's value, it is holding the address of VR2, and the address of VR2 is basically this one, 00000008. So similarly, that thing will be printed on here, 0008, and after that 0x00000000C, 48C, because int, all three variables were basically integers, and integers in C++ are of 4 bytes. So each was occupying 4 bytes in the RAM. That is why you can see the difference of 4 in the addresses. So now we have displayed them, and this is what our console will look like. So let's change some things in this particular code and see what happens in the console. Basically, we need to draw a bigger console for that. The console is basically bigger. Now console is bigger, and we assume that just like we had a PTR VR1 variable that was basically being displayed on the screen. Before that, we have a Cout VAR1 that is being displayed on the screen. And after that, and then we have VAR1 plus 1 that is being displayed on the screen. So similarly, here we had a PTR underscore VAR1 being displayed on the screen, and after that we have a PTR underscore VR1 plus 1 that is being displayed on the screen. We can assume that there is an end here, so that we can go on the next line. So when this particular code will run, these two lines are the new lines that we have included in this code. When these two lines of the code will run, what will happen? Cout VAR1, we know that when we write the name of the variable, it basically prints on the console whatever value that was stored in VR1, and VR1 currently used to hold value 5. Next, we go to the next line, and after that we do VAR1 plus 1. It means that we are adding 1 to whatever was stored in VAR1. So whatever was stored in VR1 was 5. And we were adding 1 in 5. So basically 6 got printed on the screen, and we have an end. We go to the next line. Now we display PTR VR1's value. So PTR VR1 used to hold the address of variable 1, and that address was this one, So now the thing that will be displayed on the screen will be 0x000004. Then we go on to the next line, and now the important difference comes here. We have a pointer variable ptr underscore vr1, and we are doing +1 in that, just like we were doing +1 in the normal variable. What it used to do, it used to add 1 to whatever was stored in vr1. However, pointer variables are different from normal variables here, in the sense that when we do ptr underscore vr1 +1, it does not simply add 1 to whatever was basically stored in ptr vr1, because it is not a value now, it is a certain address, and addresses are dealt in a different way than the values. So what is that thing that basically gets added in the ptr underscore vr1? So the thing that gets added to the pointer variable is basically whatever is written here gets multiplied to the size of variable, size of variable to which the pointer points to. So just like we did a normal variable name +1, what happened on the console was 1 was added to whatever was stored in vr1. However, when we do ptr underscore vr1, that is a pointer variable, and we write +1 with that, it is not actually adding 1 simply to whatever was stored in ptr underscore vr1, which was this number. However, that gets added, the thing that is basically being added to the pointer variable ptr vr1 basically first gets multiplied with the size of variable to which pointer was pointing to. Pointer was pointing to an integer variable, and ints have 4 bytes of size in C++, we know that. So whatever was 1 here, whatever was being added to the pointer variable 1 ptr vr1 does not simply add 1 to whatever was stored in ptr underscore vr1. However, that value that is being added first gets multiplied to the size of the variable to which the pointer is pointing to. So the pointer was pointing to an integer here, so this thing basically gets replaced by 4. So it means that the one that was getting added here was actually multiplied with 4 first at the back end. So when we are doing ptr vr1 +1, what it actually does is that it actually adds 4 in this pointer variable's address that it is holding. So 1 gets multiplied with 4, and this 4 basically gets added to that pointer variable. That is where the difference lies between the normal variable and a pointer variable. When we do +1 in a normal variable, whatever is stored in vr1 gets added by 1 and is displayed, just like 5 added with 1, 6. However, when we do +1 in the pointer variables, it just does not add 1 to whatever was being stored in the pointer variable. What happens is that 1 or whatever is written here, that constant 1, 2 or 3, that gets multiplied with the size of the variable to which the pointer is pointing to. All the pointers here were pointing to integers. So and integers have a size of 4 bytes. So this gets multiplied with 4, and actually 4 is being added to this thing that was written here, that was basically the name of a pointer variable. So now the thing that will be displayed on the screen will not be this thing. This will not be displayed on the screen. The thing that will be displayed on the screen will be 0000000C. That is basically the difference between a normal variable and a pointer variable, and that is why it is important to write star here so that the compiler knows how to treat it, either to treat it like a pointer variable or to treat it like a normal variable. That is why this thing is very important, so that compiler can handle the two things in two different ways, because simple variables hold values, however pointers hold addresses. So that is basically one of the concept that needs understanding before jumping ahead. Another concept that is basically building on top of this one is that what happens if we write a dereference operator with whatever code that we have written here. Let's remove this code first and write that thing again. For example, we were writing here we were writing cout and ptr underscore vr1. So this was a certain address. We know that dereference operators are basically used when we want to access a certain value from a certain address. When we write a star, that is basically a dereference operator along with the name of the pointer variable, that basically dereferences the value from the address that the pointer variable is basically pointing to. So ptr vr1 is basically pointing to this particular address, and if we want to access this particular value, we need to put an asterisk sign before this pointer variable name. This basically means that we are dereferencing whatever value that was basically being accessed by this pointer variable. This pointer variable basically holds this address, and if we want to pick the value from that particular address, we have to put the dereference operator along with the name of the pointer variable. Similarly, if we write NL here and we write dereference operator ptr var1 plus 1 or plus 2, like, and we write ptr var1 plus 2 here. What happens in that case? We know that whenever we are adding something in the name of pointer variable, it just does not simply add that value in that in whatever was stored in that particular variable. It first multiplies that thing with the size of the variable to which the pointer variable was pointing to in bytes, and integer is basically of 4 bytes, so it multiplies that value with 4 first, 2 gets multiplied with 4, and then that thing gets added, that is basically 8, to whatever was stored in ptr vr1. So ptr vr1 used to hold this particular value 00000004. So when we do ptr underscore vr1 plus 2, it does not go 2 addresses ahead. No, it does not do that. It goes 8 addresses ahead because the pointer variable was pointing to an integer variable. So it goes 8 addresses ahead. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it goes to the ninth address. Plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8. So it comes here. It comes at this particular address. Now when we write ptr underscore vr1 plus 2 and dereference that thing, it basically picks the data from this particular address, that is basically C. And on this address we know that the variable 3 is located. So whatever value that will be present on the 4 bytes here will be accessed by the dereference operator. So here what will be printed if we extend our console here. So by writing this particular line, what was printed on the screen? 5. And by writing this line of the line of the code, what will be printed on the screen is basically 15. Because by doing plus 2 after the pointer variable's name, we have technically added 8 addresses to the address that was basically stored in the pointer variable 1, ptr vr1. And adding 8 to that particular address meant that we arrived at the third variable here, and writing dereference operator here meant that we were accessing the value from this address. So that is why 15 gets printed on the screen. Similarly, if we had plus 1 here, and it would have basically been multiplied with 4 and 4 would have been added, and now if we would have been dereferencing that value, that would have been dereferenced from this particular address. So 10 will be printed on the screen in that particular case. So that is basically the pointer basics that we had to revise. Now let's see how the arrays and pointers are related to each other. Now when we have established the basic understanding of pointers and we have cleared the basic fundamental concepts, we can move on to some advanced concepts. The next concepts that we are discussing in this session are basically of pointers and arrays and the similarities they hold among themselves. Pointers and arrays are similar to each other in a lot of different aspects. Pointers and arrays basically support same sets of operations as each other. We will look at those operations in detail here. First, let's define and initialize an array. It is a 3-element array named marks of data type integer, and it basically holds 3 values 7, 9 and 5 that are arranged in the memory just like this. And we know that the first element of the array is at index 0, the second is basically named as index 1, and third marks of 2. So that is basically our understanding of arrays. So just like in the last case we had 3 different variables, and we could access the address of every single variable by writing the ampersand sign with that. We know that the elements of an array are basically a lot of variables that are grouped together to form an array so that they can be dealt with collectively. Similarly, if we write marks of 0, it basically gives the value 7. However, if we write ampersand marks of 0, it basically gives an address. Just like we wrote vr1, it gave value, ampersand vr1, it used to give an address. Next thing, marks of 1 gives 9, ampersand marks of 1 gives a certain address. Similarly, marks of 2 gives 5, ampersand marks of 2 gives a certain address. So this is basically our fundamental understanding of the arrays up till now. However, if we start to understand some further details, we know that the array name is basically a thing that is serving as a pointer to the first element of the array. What does this thing mean? It means that when we write cout marks, just like if we write cout marks of 0, it will print a 7, and we write marks of 1, it will print a 9, and if we print cout marks of 2, it will print 5. What if we just write cout marks? What will it print in that case? In that case, if we just write the name of the array, this was basically the name of whole array, and these were the names of individual elements of the whole bigger array. When we write cout marks, that is just the name of the complete array. What we get is basically an address, and that address is basically of the first element of the array. The address of the first element of the array, we know that will be this particular address. The address of the second element of the array is basically this address, and the third element of the array will have the address that is basically this one. Just like we saw 3 variables that were placed on top of each other in the RAM in the last case, they were basically starting from addresses 4, 8 and C. So when we just write cout marks, it prints an address, and that address is basically same as when we print the address of the first element of the array, or the address of the 0th index of the array. So what we can infer from these 2 lines of code is that array name basically serves as the pointer to the first element of the array, which in turn means that writing cout marks is the same as writing cout ampersand marks of 0. And it basically says us that an array name is nothing but a pointer to the first element of the array. And even better if we say it like array name is nothing but a name that serves as a pointer to the first element of the array. Why do we say serves here or behaves here? Behaves as the pointer to first element of the array. The reason is that it does not hold all the functionalities that a similar pointer would hold. There it has some limitations. However, in a lot of ways it can act as a pointer to the first element of the array. So it acts as a pointer to or serves or behaves, we can say all these things. The array name basically serves as the pointer to the first element of the array. And why do we say serves? We say serve here because the array names cannot be assigned any other addresses. However, pointers can be assigned some other addresses. Had this difference not lied between the two things, I would have said that array name is a pointer to the first element of the array. However, that difference exists, and that difference is that we cannot basically assign other addresses to the array names. However, we can assign other addresses to the pointer variables. That is why array name is not a pointer to the first element of array. However, it serves as a pointer to the first element of the array because it can do a lot of similar things. And that is apparent from here if we define an array and if we define a pointer. And if we equate number to the name of the array, number was basically a pointer variable. If we equate number, that is a pointer variable, to the name of the array, that serves as the pointer to that is serving as a pointer to the first element of the integer array named marks. In that case, basically we can do that. We can assign, this is a legal writing of code, number equal mark, because number is a pointer variable and mark, and we have established right now, can serve as a pointer. In fact, it serves as a pointer to the first element of the array. So this is basically, it can be treated as a pointer to the first element of the integer array named marks. So mark is serving as a pointer to the first element of the array, and number in itself was a pointer variable that was defined as a pointer variable. So these things can be equated to each other. Because last time number is a pointer variable defined as a pointer variable. However, mark was defined as a name of array. However, names of arrays serve as the pointer to the first element of the array. So these two things can be equated to each other. However, the reverse is impossible because once the arrays are defined, they are fixed in the memory. Remember the rail example, the rail boxes are fixed in the array. However, the pointer variables can be assigned different addresses on runtimes. However, arrays cannot be modified in their size or in their starting addresses at the runtime. And that is the exact reason why this statement is valid, why this is invalid. Because mark is a name of an array, and this has to be predefined by the compiler in the memory. It will be an array of fixed size starting from a fixed address. It cannot be changed while the code is running. However, the pointers are basically the variables that hold the addresses, and that is why they can be assigned new addresses when the program is running. So this statement works, this does not work, because array names cannot be assigned different, arrays cannot be assigned different addresses at runtime. So that is the reason why we have written serves as a. array name is not a pointer to a first element of an array in all its aspects. However, it serves as a pointer to first element of the array in a lot of its aspects. That is the proof that we saw here. Now if we want to dereference something from the array name, we know that array name is basically serving as a pointer to the first element of the array. So if we write a dereference operator with that, what will happen on the console? If we have a console, marks is basically this particular address, and when we are trying to dereference something from this particular address, 7 will be dereferenced. However, in the similar fashion, if we are writing marks of 0, we know that it also gives us the same 7 that it gave us here. So in both these lines of code, 7 will get printed on the screen. And if we write marks plus 1, now we know that marks is not a pointer. However, it is an array name, and array name can serve as a pointer to the first element of the array. So when we do marks plus 1, what happens is that 1 gets multiplied with 4, just like in the example we saw before. 4 gets added to the address that was basically here, and it was an address as we saw here कि जब हमने cout marks किया था तो हमें पता था कि marks basically holds an address because it is acting as a pointer to the first element of the array. It means that it is holding the address of the first element of the array. So when we added 1 in that particular address, it technically added 4 in that address by multiplying that 1 with 4 at the back end because it was an integer array. So 4 gets added in that particular address, and it brings us to this particular place. Marks plus 1 is basically this particular place. And if we dereference something now, it will basically be dereferencing, we will basically be dereferencing 9 here. Similarly, it is in the exact same fashion that we write marks of 1. When we write marks of 1, it basically gives us 9 on the screen. So you can see that there are similarities among pointers and arrays. Array name, some of which I summarize it now, and some of which are that array name is basically an address as we saw here, and that address is basically of the first element of the array. So array name basically serves as the pointer to the first element of the array. Second, when we are writing marks of 0, we are basically incrementing, we are basically jumping to the next elements of the array. Like marks of 0, took us kept us at the first element of the array. Marks of 1 took us to the second element of the array. Marks of 2 takes us to the third element of the array, and so on. It is the same case when we are doing with the pointers. When we are doing plus 1, it is not moving us 1 ahead. It is basically taking us to the next element. Plus 1 technically means plus 4. Plus 2, had there been a plus 2 here, it would have technically meant plus 8 because 2 gets multiplied with 4. It would have meant plus 8. And the same thing would have meant here marks of 2, that we are moving to the second element of the array. So that is basically the similarities between the pointers and the array. Both support a lot of same sets of operations. Here the important thing to notice is that marks was not defined as a pointer variable as some pointer variables were defined as pointer variables in the past example. Marks was defined here as an array. However, the array names can serve as the pointer to the first element of the array. So when we wrote cout marks, it printed out an address, and when we dereferenced the name of the array, it gave us the value of the first element of the array. Similarly, it is same like doing marks plus 0. Marks of 0 and marks star marks plus 0 will give the same result because pointers and arrays support the same set of operations. So these are the similarities between pointers and arrays. Now we will look at how we can pass arrays to the functions. This mechanism is known as pass by address or call by address. It is also referred sometimes as call by reference because there is a lot of similarity between call by reference or pass by reference and call by address and pass by address if you call it this way. So that is why sometimes we call it call by reference. However, I prefer to keep it separate from call by reference so as to distinguish the use of reference variables from the use of pointer variables in call by reference and call by address respectively. So here when we are using functions, we know that there are basically three things that we have to incorporate in our programs: the function prototype, the function definition, the function call. In function prototype, the thing that will be a little bit different from the earlier discussions is that we need to include square brackets in order to indicate that we are passing array to a function. Arrays are basically represented by square brackets. So we write square brackets in the function prototype so as to indicate that the arrays are being passed to the functions. Just like in call by value, we had the prototype something like this, and in call by reference we had the prototype like int ampersand int ampersand, so as to indicate that the reference variables will be used here. Here we have int square brackets so as to indicate that the array will be received here, or there is one other purpose that we'll see here as well. So we have to write square brackets in the prototype to indicate the passing of array to the function. Second thing is function definition. The function is defined here is basically a display function that indicates that we are just outputting the data stored in an array that was already defined and initialized in the main function. And third thing is function call, where basically we send the array to the function by writing the array name. What does these two things mean at the back end? This basically needs some understanding. We know that when we are doing call by value, how the link is established between the function call and function definition is that we have int num, for example, here, and there is numbers written here. So that is how the link is established here. When we have call by reference, we have a reference variable defined here, int we can say reference variable num written here, and number is coming from here, and that is how the link is established between the reference variable and the variable that was received from there. How that link is established when the arrays are being passed to the functions needs understanding. This thing int number square brackets, this basically means that numbers is basically a name of an array that is serving as the pointer to the first element of the array. We saw in the discussion before that here, by the way, we are defining a new array, and when we write int numbers, this thing, the array is defined. Int numbers, this thing, the array is defined. Although if we write 10, it will be an explicit definition that there will be 10 elements coming ahead, but if we write just this int numbers this and write names after that, the array is defined by just this as well. And we also know that one thing, the array is already defined like this, can be defined like this, and has been defined like this. Second thing, the array name is basically serving as the pointer to the first element of the array, i.e. array name basically points to the starting address of the array. So we know that at the back end, numbers, this link establishment is basically equivalent to this particular thing here. Just like यहाँ पर जब when we were using call by value or call by reference, these things were equal. Numbers was written here and num or ampersand num was written here. So both these things were equal. Here, when we have written these two things, this link establishment is basically equivalent to this thing. int star numbers is equal to ampersand marks of 0. And what does this mean? This means that numbers is a pointer, is serving as a pointer variable. That's why equivalency and not equality. Numbers is serving as the pointer to the first element of the array, that is basically numbers itself. The array name serves as the pointer to the first element of the array, or the this basically number holds the starting address of the array. So addresses are present in the pointers. So this link establishment is basically equivalent to int star numbers equals ampersand marks of 0. Ampersand basically gives us an address, and address of what? The first element of the array named marks. And we also know that marks is giving us the address of the array, simply the starting address of the array. So these two things should not be confused, that they are two variables, simple variables. This thing here is basically acting or serving as a pointer, and this thing is an address. This thing is not a simple variable. This thing is an address. We know that when we write just the name of the array, it is basically an address. And we also know here that when we define an array, we are actually defining a pointer to the beginning of the array. So these two things are basically equivalent to these two things. That is how link establishment is done at the back end. This is a pointer, you can visualize it as a pointer, and this is an address, and addresses go to the pointers. Addresses go to the pointers. That is how the link is established. Just like one value can go into another variable, one value can go into another value. One variable can be named another variable. Similarly, addresses go into the pointer variables. One array can be basically, one array name, that is basically an address, can be sent to the function where the receiving person is basically kind of a pointer or a thing that serves as a pointer. So this is one thing that is passed as an argument during the function call, and the second thing is basically the size. Because by the first argument we had passed the starting address of the array. Now we know that where in the memory the same array starts. Now we need to know its finishing point as well, and that is basically accessed by the size, and that is why the need for the second argument during the function call, and that should also be indicated in the prototype that we will be receiving a second argument here as well. First variable was basically an address, and array name is basically the starting address of the array. Second thing is basically the size that takes us to the ending of the array. So these two things need to be passed during the function call when we are passing arrays to the functions, and that is basically the name of the call by address or pass by address, because we are passing the address or calling or making the function call while the address is being passed. That is why when the arrays are passed to the functions, they are known as call by address or pass by address, and they always have a supporting argument that is basically the size of the array, so as to take us to the ending of the array. Starting address and the size that takes us to the end of the array. So here it is simply displayed. Here numbers, we can use numbers in order to access the same array that was marks. So if we draw this array here, we have drawn the marks array here. It has basically 5 things here. We know that the array name points, array name is basically the starting address of the array. We also know that marks of 0, marks of 1, marks of 2, marks of 3, marks of 4, marks of 5 give us the values of the address. However, now we also know that there is a pointer variable numbers here, that is basically pointing to the same address as the marks was pointing. Marks was pointing here, and so as numbers. Numbers is also pointing to the same address where the marks was pointing, because the pointer holds the same address and it has been transferred to it during the function call. So now marks and numbers both point to the same address, and just like we did mark of 0, we can do numbers of 0, number of 1, number of 2, number of 3, number of 4, and they will give us the elements of the same array in the same place in the memory. Similarly, we can also do star numbers plus I will first be 0. We also know that we can also write marks of 0 is basically equivalent to star marks plus 0. Similarly, marks plus 0, round bracket here. Similarly, we can also write star numbers plus 0. Numbers plus 0. So all these things are equivalent because in the deep down pointers and arrays work in a lot of similar ways. That is why these equivalencies can be established, and the operations that are supported by pointers are also supported by arrays, and this call is known as call by address because we are passing the address, and addresses are passed to pointer variables, and when the arrays are defined, we actually are making a pointer variable that can do almost all the things of a pointer except being replaced by some other address, because arrays cannot be defined at a new address during runtime. So that is basically the summary of all these things. Here the value was being pointed, here the address is being passed. This was passed by value because value was passed, this was passed by reference because reference variable was used, this is passed by address because the address is being passed, and address is passed in the pointer variable. And when we define an array just like this, we can also write, had we written here int star numbers, it would have also been the same thing. Another equivalency can be established, just like this establishment of the link is equivalent to this thing. This particular thing alone can be considered equivalent to this thing. However, the difference here is that this numbers could have been assigned a new address, and this numbers could not have been assigned a new address, and this numbers could have been assigned a new address during the runtime here. So we can just use the new name of the array here, just like we used to use the new names of variables that receive the values coming from the main. Here we can use the name of the array, and all the operations will remain the same. We can also treat it like a pointer if we define it this way. So in summary, the three steps are: we have to write the square brackets to indicate that we will be receiving an array, passing arrays to functions. Second thing is basically we need to pass two arguments during function call. The first is the array name, and array name is basically the starting address of the array. Second argument is the array size, and that basically takes us to the end of the array, thus allowing us to access the complete array with the starting address and the size of the array. And the third thing is basically function definition. There can be multiple ways, as I said, that we can write int star numbers here, and we can write int numbers this thing here. However, both the things will be similar in almost every aspect, except these numbers can be reassigned another address here. However, this cannot be. So if you want to ignore this point, you can ignore it as well. However, both these things will be the same. And here, just like we could have done cout marks of 0, marks of 1, marks of 2, marks of 3, marks of 4, marks of 5 here. This way we are doing it with numbers here, this way. Just like we used to use the new variables that receive the value here in this function, we are using the new name of the pointer or the new name of the array when we are using the arrays here. The arrays defined here. The some last point is that why the arrays are passed by call by address or passed by address. So call by address or pass by address basically does not need to pass all the values of the arrays to the function, or to define a lot of reference variables in the function definition. That is why saving us both the time and the memory, and also improving our coding. So That is why pass by address is used when we are passing arrays to functions, because we just need to pass the starting address of the same array in the memory. There is no new memory that will be made, and there is no new reference variable that will be assigned. There is no extra tasks, because if you have a 500, 5000, 5 million long array, it cannot be passed. We cannot pass all the values by call by value to the function. We cannot define a lot of reference variables in order to send the basically all the array, or basically name all the elements of the array differently. And the other reason is that the name of the array is basically an address, a starting address simple. So that allows us to make the function calls using call by address or pass by address when we are passing arrays to the functions. So that is pretty much it from today. One last thing is the correction that I needed to clarify here. At the 14:33 time during the video, I say that the address that should be written on the screen should have a C at the end. However, that is wrong. It should have an 8 at the end, because we were doing in the code +1 in the pointer variable there, and +1 means multiplying 1 with 4. That technically means +4, and the address before that was 0x00000004. So the thing that should have been written on the console and said by me was 0008 and not the 000C. So that was the correction.